Okay, so for this video, we will be discussing the derivatives of hyperbolic functions. But before we go to the derivatives, so let us first define hyperbolic functions. So hyperbolic functions are defined in terms of exponential functions, where the most fundamental are the hyperbolic sine and hyperbolic cosine. Okay, I'm sorry. So again, the most fundamental are the hyperbolic sine and hyperbolic cosine. So the hyperbolic sine here is defined as the hyperbolic sine of x is equal to e to the x minus e to the negative x over 2. Okay, so this should be memorized. And also, the hyperbolic cosine of x is equal to e to the x plus e to the negative x over 2. Okay, so notice their difference, so you should memorize. If it's sine, hyperbolic sine, it's minus. If it's hyperbolic cosine, it's plus. Okay, and all the other definitions, all the other hyperbolic functions are very similar with the trigonometric functions. So as you can see here, the hyperbolic tangent of x is equal to the hyperbolic sine of x over the hyperbolic cosine of x. Similar with the trigonometric function tangent, where tangent of x is equal to sine of x over cosine of x. Okay, so in hyperbolic functions, this is the definition of hyperbolic tangent is still similar. Also with the hyperbolic cotangent, which is defined as the hyperbolic cotangent of x is equal to the hyperbolic cosine of x over the hyperbolic sine of x. The hyperbolic secant of x is the reciprocal of the hyperbolic cosine of x, and the hyperbolic cosecant is the reciprocal of hyperbolic sine. Okay, so those are the definitions of the hyperbolic functions. So hyperbolic functions also has identities, which looks familiar because they are somewhat similar with the identities of trigonometric functions, but they are there's actually a lot of difference. Okay, so take a look at the first example. The hyperbolic hyperbolic cosine squared of x minus hyperbolic sine squared of x is equal to 1. Okay, in the trigonometric identity, it's sine squared x plus cosine squared x is equal to 1. Okay, so here it's different. It's minus. It's hyperbolic cosine squared of x minus hyperbolic sine squared of x. And another identity, hyperbolic tangent squared of x plus hyperbolic secant squared of x is equal to 1. Another, hyperbolic cotangent squared of x minus hyperbolic cosecant squared of x is equal to 1. And then we have double identities. Hyperbolic sine of 2x is equal to 2 hyperbolic sine of x hyperbolic cosine of x. Okay, so that's similar to the double angle identity for sine, right? But the double for cosine, hyperbolic cosine is equal to hyperbolic cosine squared of x plus hyperbolic sine squared of x. So notice the difference there, okay, with the double angle identity for cosine in the trigonometric function. Okay, so in the double angle identity for trigonometric function cosine is cosine 2x is equal to cosine squared x minus sine squared x. Okay, in the hyperbolic cosine, if it's hyperbolic, so it's plus. Okay, and then these are, I think, derived from here. So substituting them and then transforming. Okay, so now let's go to the derivatives, okay, of hyperbolic functions. So as you may see, again, the derivatives are quite similar with the derivatives of trigonometric functions. Okay, with the only difference in the derivative of hyperbolic cosine, the derivative of hyperbolic cosine and the derivative of hyperbolic secant. Okay, so the derivative of hyperbolic cosine of u with respect to x is equal to hyperbolic sine of u times du over dx. So it's noticed that its difference with the derivative of the trigonometric function cosine is the negative sign. Okay, so the derivative of cosine in the trigonometric function is negative sign, but in the hyperbolic function it's positive. Okay, the hyperbolic sign is positive. Okay, and also for the second one, as I've mentioned earlier, in the trigonometric function, the derivative of the derivative of secant is positive secant tangent. In the hyperbolic function, the derivative of hyperbolic secant is negative hyperbolic secant of u, hyperbolic tangent of u, then multiplied by du over dx. So in the formulas, we can still see the chain rule. Okay, so where du over dx is the derivative of the arbitrary function u. Okay, so where u is a function that can be differentiated with respect to x. Okay, so again, you should memorize those formulas because those formulas will be used for the derivatives. And again, also review and memorize the hyperbolic identities because you can use them in simplifying the functions and also the derivatives. Okay, so let's solve some examples. Okay, so let's have some examples. So find the derivative of the following. So first one, we have y is equal to hyperbolic tangent of 1 minus 3x. So this is a very straightforward problem. So a direct use of the formula. So for letter A, again, we have y is equal to hyperbolic tangent of 1 minus 3x. Okay, so here we will be using the formula for the derivative of hyperbolic tangent. So the derivative with respect to x of the hyperbolic tangent of u is equal to hyperbolic secant squared of u times du over dx. Okay, so from here, our dy over dx therefore will be the derivative of this. So the derivative of hyperbolic tangent is hyperbolic secant squared of u. Okay, so where our u is 1 minus 3x. So therefore, the derivative is hyperbolic secant squared of u. So our u is 1 minus 3x multiplied by the derivative of u with respect to x. So derive 1 minus 3x. So the derivative of 1 minus 3x is 0 minus 3. So that is negative 3. So therefore, very simple, the derivative of y with respect to x is equal to, we will have here negative 3 hyperbolic secant squared of 1 minus 3x. Okay, so for our next example, so we have x is equal to hyperbolic cosine squared of 3t. Let's rewrite the function. X is equal to hyperbolic cosine squared of 3t. Okay, so as you have noticed, so this now will not be a direct use of the formula because we don't have the derivative of hyperbolic cosine squared. Okay, what we do have is the derivative of hyperbolic cosine only. Okay, so but if you know enough, so you can see that this can be derived using the general power formula. So we just have to express 2 explicitly so that we can see that it's a general power formula. So x is equal to hyperbolic cosine of 3t and then squared. Okay, so following the general power formula, so our derivative now of x with respect to t is equal to, so using the power formula, so multiply the exponent as the coefficient, so 2 times, copy, hyperbolic cosine of 3t raised to 2 minus 1 for the power formula. So after that, so multiply it by the derivative of the function inside the parenthesis. So the derivative of cosine, so if you recall from the formulas earlier, the derivative with respect to x of hyperbolic cosine of u is equal to positive hyperbolic sine of u times du over dx. Okay, so the derivative now of hyperbolic cosine is hyperbolic sine. Okay, of u, our u is 3t. So hyperbolic sine of 3t and then multiplied by du over dx. So du over dx is the derivative of u. So our u is 3t, therefore its derivative with respect to t is 3. Okay, so therefore we can now simplify it as 2 times 3, or we can combine this first. So we have 2 hyperbolic sine of 3t hyperbolic cosine of 3t, okay, times 3. Okay, so recall the identity earlier that the hyperbolic sine of 2x is equal to 2 hyperbolic sine of x hyperbolic cosine of x. Okay, so therefore this can be expressed as, our x here is 3t. Okay, so therefore 2x is equal to 6t. So therefore this can be replaced with, hyperbolic sine of 6t, and then multiply it by 3, so therefore it will become 3 hyperbolic sine of 6t. Okay, so again, the identities came in very handy in simplifying the functions. Okay, so next is letter C. So for letter C, we have y is equal to 1 minus x squared, 1 minus x, and then squared, then hyperbolic sine of 2x. Okay, so this problem now can be solved using the product rule. Okay, so applying the product rule, so our dy over dx is equal to the first factor 1 minus x squared multiplied by the derivative with respect to x of the second factor. So the derivative with respect to x of hyperbolic sine of 2x, and then plus the second factor hyperbolic sine of 2x multiplied by the derivative of the first factor. So the derivative with respect to x of 1 minus x squared. Okay, so deriving, so we will have 1 minus x squared multiplied by, so the derivative of hyperbolic sign. So from the formula, it's hyperbolic cosine. And then copy 2x. And then multiply it by the derivative of 2x with respect to x. So that is 2 plus copy the hyperbolic sign of 2x multiplied by the derivative of 1 minus x squared. So this can be derived using the general power formula. So bring down 2, multiply it as a coefficient, and then copy 1 minus x raised to 2 minus 1 multiplied by the derivative inside. So it's negative 1. Okay, so next is simplify. So this will be 2 times 1 minus x squared, and then hyperbolic cosine of 2x. Okay, minus, so 2 times negative 1, so minus 2 times 1 minus x raised to 2 minus 1 is 1 minus x. Okay, and then hyperbolic sign of 2x. Okay, so that can be your derivative already, or we can factor out 2 and 1 minus x. So factoring 2 and 1 minus x, so what will remain here is 1 minus x, and then hyperbolic cosine of 2x minus, here what will remain is hyperbolic sign of, sorry, this is hyperbolic sign of 2x. Okay, so this is now our derivative. Okay, so for our last problem, so letter D, we have y is equal to ln of hyperbolic tangent squared of 3x. Y is equal to ln of hyperbolic tangent squared of 3x. Okay, so before we derive, since this is a logarithmic function, so let's see if we can simplify this. As you can see, we have the hyperbolic tangent of 3x is squared, so this is actually equal to ln of the hyperbolic tangent of 3x squared. Okay, so using the laws for logarithm, so we can transfer the exponent at the coefficient. So this will become y is equal to 2 ln of hyperbolic tangent of 3x. Okay, so deriving this, so dy over dx is equal to, so we have a numerical coefficient of 2, so multiply that, and then the derivative of ln. Okay, so we have ln of u, so this is our u. So remember that the derivative of the natural logarithm is 1 over u times du over dx. So the derivative with respect to x of ln of u is equal to 1 over u times du over dx. Okay, so our u here is the hyperbolic tangent of 3x. So this will become 1 over hyperbolic tangent of 3x multiplied by its derivative. So the derivative of hyperbolic tangent of 3x from the formula earlier, the derivative of hyperbolic tangent is secant squared, hyperbolic secant squared. So times hyperbolic secant squared of 3x multiplied by the derivative of 3x, which is equal to 3. Okay, and then simplify. So 2 times 3, that is 6, times. So to simplify this, we can express this in terms of sines and cosines. So 1 over hyperbolic tangent of 3x, that is hyperbolic sine of 3x over hyperbolic cosine of 3x multiplied by hyperbolic secant squared of 3x, that is 1 over hyperbolic cosine squared of 3x. Okay, so as you can see, we can cancel out 1 hyperbolic cosine 3x. So this will become 6 over hyperbolic sine of 3x and then hyperbolic cosine of 3x. Okay, so but we can still simplify this. So recall again the double angle identity. Okay, so similar with the double angle identity, so we have so this is 3x, then the hyperbolic sine of 6x, okay, is equal to 2 hyperbolic sine of 3x hyperbolic cosine of 3x. Okay, if we divide both sides by 2, so then the hyperbolic sine of 3x times the hyperbolic cosine of 3x is equal to 1/2 of hyperbolic sine of 6x. Substituting that, so this will become 6 over 1/2, sorry, that is 1/2 hyperbolic sine of 6x. So therefore, simplifying our derivative, sorry, dy over dx is equal to 6 divided by 1/2, that is 12, and we have 1 over hyperbolic sine of 6x, so that is equal to hyperbolic cosecant of 6x. Okay, so this is the simplified form of the derivative. Okay, so that's it for this lesson. So again, so all you need to do is memorize those formulas and the identities. Okay, so basically this is not new. The method of solving the derivative are still similar with the derivatives of trigonometric functions. So they are formula based, and all you need to do is memorize those formulas as well as the identities to help simplify your final answers. Okay, so that's all, and see you in the next lesson.